Welcome back. Today we're with Roy Smith, who is a electrician in our local area. He's renowned throughout the country because of his time that he spent in education as well as the trades. And we're going to talk to him about GFCIs, ground fault circuit interrupters. I think this is something that our practice or our trade, they understand it a little bit, but maybe not enough to understand the importance behind it. So can you talk about GFCIs and why they're used? Let's start there as a basic thing, and then we'll get into some other questions.
The electrical code was devised for fire safety. That was its primary purpose. When I started to come talk to you today, Mark, I meant to bring my code books. I have a 1957 code book that was my first code book, and it's a 5x7 and it's maybe 3/4 of an inch thick. Today, our code book's 7x11 and probably 1.5 inches thick and not 2 inches.
Right.
Things have changed, and the things that have changed, though it was presented to be fire protection, well, now it's everything protection.
Yeah.
Fire, life, installation, safety for others.
Sure.
Goes on and on.
Right.
The importance of GFCI is the ability for a circuit to disconnect in a primary designed set of cycles of time. When they came out, they were a mess. Nothing worked.
Yeah.
Everything was a nuisance trip, be it too much voltage, no ability for 220 circuits. It was just a total disaster that we had to live with because it was part of code. Well,
Sure.
the manufacturers have straightened out that problem, and it got pretty steady for several years. And then they came out with ground fault circuit interrupters. And then they combined the two, ground fault GFIC protection. When the transition was made for the circuit protection, it was another disaster. Lights wouldn't work. It was a mess. They have straightened that around. Now the circuit protection for GFIC is an explained theory. However, the circuit protection other than GFCI is proprietary. You can't get anybody to tell you what makes that circuit protection work.
Wow.
And so is Roy Smith's opinion, and
Yeah.
strictly don't hold this on me, or hold it strictly to me. I think it's a money grab.
Yeah.
If they're selling you something that they can't give you the theoretical explanation for it, then what does it do?
Yeah.
I mean, how does it do it? And they won't give you that. That's proprietary. So, does it work? Yes, they've made the corrections. Now it works. Now it's a requirement for SPA's 220 GFCI, and that wasn't possible years ago. So the protection of the time frame for GFCI to disconnect that circuit or make it inoperable with a limited amount of cycles of electricity is absolutely wonderful.
Yeah.
And it's something that people should use if they aren't using.
Right. Well, most people, they're used to receptacle outlets that have, you know, the standard push button resettable GFCIs in it. But I know there's a lot of guys, and I've done it many times, that you can get around that code because it's required for us being that we're outdoors. You can hardwire your transformer in a J box with a, you know,
Yes.
with a cover. That way
Yes.
you don't have to have the GFI.
Yes.
So I was just wondering, any thoughts about that or any
Well,
worries or concerns?
Yeah, Mark, we talked about this in another video, but it's my opinion that there is no way to install a low voltage transformer that's not enclosed.
Mhm.
You can't do it. How do you protect the incoming voltage? It can't be in the open or it's
Right.
exposed. There's no hidden magic behind the transformer to make the connection. You either make the connection at the transformer and you have exposed screws that you're using, or set screws, or stab ins, or whatever. But it's exposed wiring, and that's against code.
Hmm.
So to have a transformer somewhere that isn't covered, well, then you,
Now, when you're saying covered, you mean just the outer shell of, like, when we buy our transformer units, there's usually, it's a stainless steel shell, and then you've got your transformer with the windings on the inside that's protected and isolated. And then a lot of times, especially with pool and spa rated transformers, there's Faraday shield to isolate the 120 side from the 12 volt side.
correct, and that's a code requirement.
Yes.
Two voltages cannot be exposed in the same enclosure without a barrier.
Okay.
If there's a barrier,
Mm-hmm.
but that doesn't keep the line voltage side from being GFIC protected.
Right.
And if it's protected at the GFIC from the line voltage, well, the secondary voltage is also protected.
Mm-hmm.
Downstream
Yeah.
is always protected.
Yes.
Let's say you go into a house that was built in the 1950s, it has no grounds.
Mm-hmm.
Has no grounds. Do you rewire the house? No, you take out the receptacles and put GFIC receptacles in there. The circuits that are downstream GFIC receptacles are dual fed, line and load.
Mm-hmm.
The load side goes to the rest of the branch circuits that are on that circuit, and they're now GFIC protected. Now you've met current code.
Oh, okay. Good. Interesting. What about hardwiring in? Is that, it's pretty easy to do, but is there, I guess, what are some of the potential problems with that you've seen or know about? You know, if somebody like us, we're not licensed electricians by trade, so, I mean, where can complications come in there?
You do not have to be a licensed electrician to check a circuit.
Okay?
If the circuit's hot, you do not have to be a licensed electrician to turn off the breaker.
Okay.
Period.
All right.
If it's hot, turn it off. Do all your connections.
Yeah.
You do not have to be a licensed electrician to land this circuit.
Okay. What about, can you talk a little, I know this is a little off topic of GFCIs, but talk about connections. Because I think that's a big problem, you know, using good, solid, proper, you know, connections, mechanical connections.
Well, mechanical connections are an interesting thing. For years, copper wires were twisted together and you ran through the house and you had a hot pot of lead and you dipped the wires that you connected in the hot pot of lead and then you taped them up. That only is being said because of my age.
Yeah.
If you say knob and tube wiring to
Yeah.
people nowadays,
Yeah.
they don't have
Like,
any
what?
clue what you're talking
Yeah.
about. They don't know what a knob is and they don't know what a tube is.
Mm-hmm.
And it just so happens as you can see, folks, I'm not brand new. I know what that stuff is. The things have changed over the years. They came out with twist-on circuit connectors. They were a porcelain type of machine. There was no steel, no internal coil, helicoil inside them. They were just porcelain, and they were threaded on the inside, and that lasted for several years.
Oh, okay.
Then they came out with red heads and yellow heads and gray heads and blue heads,
Yeah.
which is what we all have today.
The wire nuts.
Wire nuts.
Yeah.
And the wire nuts have a helicoil spring inside of them, and you tighten them on as tight as you can get them, and they're absolutely perfect. They have double-ended butt slices that you can use for landing wires. That's a single tube that has two screws on the outside of it, one for incoming, one for outgoing.
Right.
They can be, but then you must wrap it with rubber tape and Scotch tape to at least 1.5 times the size of the installation of the conductor. I don't know if that makes any sense to anybody, but the landing of wires is very important.
Yeah.
One roll of black belt tape over a connector isn't satisfying code.
Right.
So you at least half lap to where you're getting the double insulation value to the termination.
Right. Well, we're concerned with, like, in our trade, because we're all outdoors, we're in grade most of the time. So now you're dealing with moisture and water and, you know, dealing with those elements and the ground where the chemical reactions in the soils with, so that's why we waterproof our connections.
They make
So,
a connector that is a epoxy encased covering.
yep,
And it's impervious to water,
yeah,
totally. So I would think that would be a good device to utilize for installation.
sure. Okay. Any other thoughts on GFIs and, or GFCI, sorry, as it relates to transformers and our guys working with them towards, what about the duration? How long should these last? Because that's another issue. When let's say we have an outdoor receptacle with a bubble cover and you've got a GFCI in there, how easy is it for moisture and water to get into those systems? Because it happens and then they fail over time or they stop.
Well, there's a term used in our trade, and it's called weatherproof.
Yeah,
I have never seen anything weatherproof.
yeah,
Is it weather resistant? Yes.
yeah,
Does it do a good job of keeping out direct rain? Yes. Does it prevent moisture? No way. It happens.
yeah,
I have utilized over the years hundreds of times providing a drain hole in the bottom of a box.
okay,
1/8" drill bit.
yeah,
I don't think it's legal,
oh, really?
but I know it works.
Yeah. Makes sense, because the water always gets in conduit boxes.
Condensation, if nothing else.
Yeah,
In our area right here, and I'm speaking of Sacramento, and I don't know where you're seeing this being shown from, but in Sacramento, we can have a 50-degree differential in temperature.
yeah,
That's not strange.
yeah,
That happens. When you have that, condensation happens. This morning when I got up, it was 43 degrees.
right,
It's gonna be 81 today.
right,
So to think that there's not gonna be moisture content, that's not very smart thinking.
Is there anything that we can apply, let's say, to the back of the GFCI or the side where the conductors are secured, or anything like that, like a spray or anti, well, to prevent water or any kind of oxidation and things like that from happening, or
Mark,
should
that's a good question, and the answer is I know of nothing.
Okay,
They all have gasketed covers.
yeah,
The gasket cover covers the inside, and the only thing that's exposed, not gasketed, is the receptacle itself and the buttons.
mm-hmm,
So all of the mechanics of the GFCI is protected. Against water, not moisture.
right. So it doesn't matter, probably.
Yes.
They're gonna fail eventually.
Yeah, but the longevity, you know, over the years, GFCIs and ground fault circuit interrupters have made tremendous strides. I mean, the nuisance tripping and all of that stuff is pretty inconsequential to most applications.
Okay.
I mean, it's pretty good stuff. And the longevity is, I have GFICs out in my pasture,
Mm-hmm.
because I had a project that I was going to do that I never came to fruition, but anyhow, they're still there on
Yeah.
4x4 posts, and they've been out there 20 years and they still
Wow.
work, so.
Nice. Well, how about this as an alternative? I'm just throwing this out. Let's say instead of having the GFCIs in a receptacle box, bubble cover like the standard deal, what if you did just the J box with a flat cover, you hardwire the transformer in there, and then if that, hopefully if it's an isolated circuit, do you do your GFCI back at the main panel or no GFCI?
Absolutely, well, I'm not an advocate for no GFCI.
Okay, so, but do it back at the panel.
A breaker, GFIC breaker.
Yeah,
Yeah,
that
no,
probably would be last longer than the other one.
more protective,
Okay,
absolutely,
great,
absolutely.
okay,
The in-use covers for outdoor receptacles became popular because of people that had the flip tops on the receptacles. When GFCIs came out, if you're doing them inside, well, they take a decor plate. It's a
Yeah.
square hole, not two round holes.
right,
And the gasket material on the flip top protector for weatherproof cover just wasn't working well.
mhm,
It's too much exposure. So they came out with the in-use cover. And so now you have a clear plastic
yeah,
over the receptacle.
right,
And does it work for rain? Pretty well.
yeah,
But does it work for moisture? Not at all, because in the bottom of that, and not in the box, but in the
cover
in-use
lid.
cover,
Yeah,
it's got big loop out holes.
right,
And so, I mean, it's kind of counterproductive.
yeah,
The application you spoke of, Mark, of having a GFCI breaker at the panel, where you have a lid, you have a dead front,
Yeah.
and it's protected,
yeah,
well, then you just have a wire connection that inside of weatherproof box with a wire nut,
mhm,
red head, yellow head, gray head, blue head, in the vertical position, i.e. coming on the top of the wires,
right,
that's a pretty good connection.
yeah, exactly. So you would recommend that too, also inside the boxes or whatever, never, always place the top of the nut if you're using nuts
Upright,
upright. Versus
absolutely.
the other way where
Absolutely.
water can fill up in there.
Absolutely,
Okay.
100% of the time.
Great,
If you get in a habit of doing that, well, then it becomes second nature.
yeah. Just,
When I'm making up a house in a residence and I have a multiple circuit coming into an outlet, and I'm making up the two hots to go back in the box, one coming to my receptacle and one going down line.
Right.
When I'm folding circuits up to go back in the box, all of my wire connectors are facing up.
Nice. Well, it's part of best practices.
Best practices.
Yeah, good.
Because anything you do in life, habit makes it reality.
Yeah,
And a habit is born in 30 days. You can take anything you do and don't do it or do it for 30 days,
Yeah.
it's a habit.
yeah,
People talk about smoking and drinking and cussing and all this kind of stuff. You don't want to do those things? Don't do it for 30 days.
yeah. There you go. That's a good idea. Wow. Well, thank you again. This was awesome. I love it.
Good.
All this, you
Good
know,
to
it's
hear.
just like absorbing more and more knowledge, content. You can always learn, doesn't matter how old you are. And that's what I try to preach, you know, through Elli, and I thank you for being here and spending time with us.
Good to be here.
This is great.
Thanks, Mark.
Thank you. Hope you enjoyed this. We'll see you next round.